Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Already we know, we introduced a Quantum Online Academy WhatsApp YouTube channel, and we recently started the online course also. For that, each and every paper I am giving the demo. First, I gave the mathematical methods of physics and uploaded in YouTube. And secondly, classical mechanics and uploaded the YouTube, and quantum mechanics and statistical mechanics also will come further. Next, we have to discuss about the electromagnetic theory. This paper is very important. This paper weightage in CSIR 45 marks. Around the 40, above 40 marks you will get in CSIR. This paper is very important paper, electromagnetic theory, right? Not only in CSIR examination, in GATE also this paper is very important. What we have to discuss in this electromagnetic theory class, demo class. First, what is the syllabus in CSIR? What is the exam pattern of the CSIR? What is the syllabus in GATE electromagnetic theory syllabus? And what are the old questions? How the questions are coming in electromagnetic theory? Can you be able to do the problems or not? You have to check it. Clear? Once again, please subscribe my channel and share to your friends to make them as a subscribers. Please encourage me. Right. Now we have to discuss the syllabus. What is the syllabus? Already I told CSIR, two varieties of the syllabus are there. One is part A, another one is part B. Part A is a core syllabus. That syllabus is completely, purely core syllabus. Part B is the advanced syllabus concerning whether it may be mathematical physics, that core belongs to the mathematical physics. Whether it may be classical mechanics, that core syllabus will belongs to the classical mechanics. Similarly, we are discussing now electromagnetic theory, that electromagnetic theory core syllabus. What is the electromagnetic theory core syllabus? Once you have to check it, right? What is the syllabus is there here? Electrostatistics. This is very important. To originate the electrostatistics, electric charge, we have to discuss about the electric charge. Because of the electric charge, electrostatic field is generated. Because of this electrostatic field and electric potential, electrostatic energy, everything we have to calculate by using a charge. Charge is a fundamental particle here. So now here we have to calculate the Gauss law and its application. This is very important. We have to calculate the electric field by using the Gauss law, Laplace equations and Poisson equation. This will come under the electrostatistics only. Boundary value problems. This is very important. Question pakka will come in your competitive exam, not only in CSIR or GATE. Any competitive exam without electrostatistics paper won't be there. Next, magnetostatistics. What is the next part? Next part is a magnetostatistics. There, Biot-Savart law. This is very important law. Ampere's theorem, electromagnetic induction, Maxwell's equations. Now you have to see the Maxwell equation. In Maxwell equation, free space, linear isotropic media, boundary conditions of the fields at interfaces, scalar and vector potential. These are very important. Gauge invariance, electromagnetic waves in free space, dielectrics, conductors, reflection and refraction, polarization, Fresnel's law, interference, coherence and diffraction. These are the phenomena under light. We have to discuss all these things. Dynamics of a charged particle in static and uniform electromagnetic field. This is very important. This part is there in advanced also. This is the core syllabus. In core syllabus, once you have to segregate, first electrostatistics is there, next magnetostatistics is there, third electromagnetic induction. This one is electromagnetic induction. Another one is a Maxwell equation, that is the fourth one, Maxwell equation. Scalar and vector potential, this is the fifth one, scalar and vector potential, and gauge invariance also you have to include here. Electromagnetic waves for different cases are there. Free space, dielectrics, conductors, in plasma also is there in the advanced part. Reflection and refraction, this entire thing, optics thing. Optics we are included here, whatever the degree syllabus is there, no, the degree syllabus, graduation syllabus, they are included. Reflection and refraction, polarization, Fresnel's laws, interference, coherence, and diffraction. These things purely optics, optical formulas. By using electromagnetic radiation, we are involving all these things. Dynamics of a charged particle in a static and electromagnetic field. This one is the another one, this seventh one. This one you have to consider as a eighth one. 8 parts. After some time I will explain how I am segregating the old syllabus, how many parts we will see. In part B, this is the advanced part. Advanced part means whatever the research is burning in this electromagnetic field, that area we are discussing. What is the advanced part? Once you have to see dispersion relations in plasma. This is very, very important. Nowadays we are using the screen. This is a plasma screen only. The digital board is plasma, interactive panel only is there. That's why easily we have to excited states are easily activating. Dispersion relations in plasma. Lorentz invariance of the Maxwell equations. Lorentz invariance of the Maxwell equations. Transmission lines and waveguides. Which one it is, Nana? Transmission lines and waveguides. Radiation from moving charges. Radiation from moving charges. Dipoles. Retarded potentials. These things are very, very important. This entire thing is advanced part only. There, dispersion relation, plasma one part. Lorentz invariance, Maxwell equations another part. Transmission lines and waveguides is another different part. Radiation from moving charges and dipoles and retard potential another important thing. These 4 parts are there. How we have to enter the exam pattern of the CSIR exam pattern? Once you have to see, almost I introduced in mathematical physics and classical mechanics all the theory explaining. Total questions you able to get in CSIR examination only 75 questions. Out of 75, part A, part B, part C is there. In part A, how many questions you will get? 20 questions you will get. Belongs to whom? Belongs to the general aptitude. This general aptitude with emphasis on logical reasoning, graphical analysis, analytical and numerical ability, quantitative comparison, series formation and puzzles, etc. Whatever the general aptitude is there, no? Those general aptitude questions you have to emphasis on these topics. What are those topics? Logical reasoning, graphical analysis, analytical and numerical ability, quantitative comparison, series formation and puzzles. These things you have to take. From that questions you will get how many questions? 20 questions you will get. How many questions you need to attempt? 15 questions. 5 questions choice is there. Each and every question shall carry 2 marks. Each and every question for lose negative 0.5 marks. Each and every wrong question you may lose 0.5 marks. This is a part A in CSIR, whom it will ask general aptitude questions. Which questions it is, Nana? General aptitude questions. Now part B. Part B belongs to the physics. Similarly, part C also belongs to the physics. In part B, how many questions you able to get? 25 questions you able to get part B. Each and every question you will get 3.5 marks. Each and every wrong question you may lose 0.875 marks. How many questions you have to attempt? 20 questions you have to attempt for this, right? This is a part B. Part A, 30 marks weightage is there. Part B, 70 marks weightage is there. Part C, now you have to see. Total 30 questions they will ask. 20 questions you may attempt. Out of the 20 questions, each and every question you shall carry 5 marks. Each and every wrong question you may lose 1.25 marks. So how many total marks? This is 100 marks per part C. This is also belongs to the physics only. Total 200 marks is there. 30 marks for general aptitude, 70 marks for physics from core syllabus, 100 marks for physics core combined advanced syllabus also. Total 200 marks out of 55 questions. Maybe if you expert in part C, that is 20 marks, you able to 20 questions you able to do, easily you will get the 100 marks. Clear? With 50 percentage, you will get the more than 98 percentile, you will get the first rank in all over India rank. So that's why you able to do. Interestingly, you have to do. This is very easy. Electromagnetic theory paper, very easy. Once you know how to handle the electromagnetic theory, to solve the electromagnetic theory, this paper is very easy paper. Clear? Now you may get the clear idea about the CSIR exam pattern. Now we want to go for the GATE. What is the GATE? This is the section 3, third paper. Mathematical methods of physics, classical mechanics. Classical mechanics, after classical mechanics, electromagnetic theory paper is there. This is the third one. Electromagnetic theory is the third one according to your syllabus. That's why they are giving in the GATE examination, they are mentioning as the sections. Now you have to see the syllabus. Electromagnetic theory, section 3 in GATE syllabus, that is electromagnetic theory. Here also similar, most of the things similar syllabus is there, except some radiation, waveguides and transmission lines and whatever the plasma, dispersion relation in plasma is there, no? Except those phenomena, entire the thing is similar, same process is there. Electromagnetic theory, what is electromagnetic theory? Once you have to see, solution of the electrostatistics. Which one it is, Nana? Solution of the electrostatistics and magnetostatistics problems. There also is there in CSIR also electrostatistics and magnetostatistics problem, including boundary value problem. There also is there. Method of images, this is very important. Compulsory one question will get in GATE examination by using the method of image. Suppose some point charge is there. So there is shadow charge also we have to assume, we have to do by using a method of image charges. Next, separation of variables by using the method of images only. Dielectrics there also is there. Conductors there also is there. Magnetic materials, multipole expansion. This is very important. Multipole expansion. Maxwell equations, scalar and vector potential, Coulomb and Lorentz gauge, electromagnetic waves in free space, non-conducting and conducting media, reflection and transmission at normal and oblique incidences, polarization, electromagnetic waves, Poynting vector, Poynting theorem, energy and momentum of the electromagnetic waves, radiation from the moving charges. Entire syllabus you have to see, almost similar syllabus is there except some 2 topics. What are those topics? I will discuss in how I am segregating the entire portion in 10 parts. They do in that time we will see. This is the GATE syllabus. Once again you have to see, here also electrostatistics is there, here also magnetostatistics is there, here also conductors and dielectrics is there, here also Maxwell equations and gauge transformation, Coulomb gauge and Lorentz gauge is there, conducting medium, non-conducting medium, transmission lines is there, polarization, electromagnetic waves, Poynting vector, Poynting theorem, energy and momentum of the electromagnetic waves, radiation from the moving point charge. Here also syllabus is there. Same syllabus is there almost except 2 topics, right? Now what is the GATE exam pattern? What is the GATE exam pattern? Once you have to see, from general aptitude you may get 15 marks in GATE. Out of 15 marks, 1 to 5, question number 1 to 5, each and every question shall carry the 1 mark only. Each and every question shall carry 1 mark only. Question number 6 to 10, each and every question shall carry how many marks? 2 marks each and every question you may get. From this is the general aptitude part. Here also same thing, general aptitude, logical reasoning, puzzles and all those things they will ask. Some diagram also they will ask. That is very easy and important questions they will ask. General aptitude one. Next, physics. Here 3 varieties of questions are there. One is multiple choice questions. One more is multiple selected questions. And third one is numerical answer type questions. 3 varieties of questions they will ask. Total marks is 85 marks for physics. What is the weightage? 85 marks. For physics, total you get 85 marks. Question number 11 to 35, you will get the 1 mark question. Question number 11 to 35, you will get 1 mark question. Question number 36 to 65, total here also you will get 55 questions only. From physics, you are getting total 55 questions only. Total 55 questions. 10 questions, general aptitude questions you will get. So, 36 to 65, 2 marks questions are there. 2 marks questions. There 2 marks questions may be, sometimes they may ask multiple choice question, sometimes they may ask some questions, multiple selected questions, some questions, numerical answer type question. For numerical answer type question, there is no negative mark. No negative mark. There is no negative mark for numerical answer type. Except this, multiple choice question, there is a negative is there 1/4. Multiple selected questions also 1/4 negative is there. This is the GATE exam pattern. Total 100 marks only. Here also you are getting 55 questions only. There also in CSIR also you have to see, here in part B 25 questions plus part C how many questions nana? 30 questions. Total 55 questions only. You are getting from physics 55 questions only. Whether it may be CSIR 55 questions only. Whether you may be get GATE examination also 55 questions only. But in CSIR there is a 3.5 marks question and 5 marks question is there. In a GATE examination 1 mark question and 2 marks questions are there. How I am segregating? Once you have to see how I am segregating. What are the reference books? Reference books, these are very important to read to cover all the syllabus. These books are very essential to buy and read. Introduction to Electrodynamics, David J. Griffith. This is the Bible of Electromagnetic Theory. Introduction to Electrodynamics, very important. Next, Classical Electrodynamics, Walter Greener. This are book also very nice. And Electricity and Magnetism, B. Ghosh, IIT Bombay, Professor. Electricity and Magnetism, Munir H. Naife, Morton B. Brussels. This book also very nice book. Foundations of Electromagnetic Theory, John R. Ridge, Frederick J. Milford. Classical Electrodynamics, John David Jackson. This book is very nice. Electricity and Magnetism, M.H. Naife and M.K. Brussels. The 2 times this book I indicated. This book is very nice book. Very nice book. If you want to buy, you can buy. And this Introduction to Electromagnetic Theory, this book is very useful in CSIR examination. Their solutions also is there. Griffith and the solutions of the Griffith also is there. Solution of Griffith. Solution of the Griffith also is there. You have to buy and you keep with you. This book is Bible of Electromagnetic Theory. Very nicely wrote Griffith. Introduction to Electromagnetic Theory. Now I segregated. Once I am informing you, once you have to see, we have to start the CSIR and GATE batch. Start from 7th January 2024 onwards. This is live plus recorded classes. Timing is every day 6 AM to 8 a.m. except Sunday. Every Sunday we have to conduct the examination based on concerning that week syllabus. Every Sunday we have to give some questions to do the to solve the questions. Then only you able to get idea how we have to solve the question. The CSIR means each and every question they will ask the formulatic and problematic oriented only. So that's why you able to know how to solve the questions. That's why we are taking the daily classes. This course duration is 1 year. 1 year duration is there. This course duration. This validity also 1 year. Maybe I have to increase after time. After some time, 6 months I will increase. Validity also 1 year. Validity also we have to take 1 year validity, right? If you are like my teaching style and if you like my teaching, you are interested, you are really aspirant to get the CSIR, you have to download, go to the Play Store, download the app, that is the Quantum Online Academy. You have to enter into the Play Store, Quantum Online Academy. Our app will display. Our app symbol is like this. Symbol will display. Quantum Online Academy symbol will display. From this symbol, you open that app and you enter your details and you join in that app. You purchase the course. Which course it is? CSIR and GATE course you have to purchase. GATE physics course you have to purchase. From that course, you have to listen each and every topic with the entire the syllabus I will cover in that app, right? So you are interested, you have to download. Clear? Now I am going to segregate the electromagnetic theory. How I am segregating, once you have to see. Total each and every paper I am segregating into 10 parts. Each and every paper, how I am segregating? 10 parts I am segregating. First part is electrostatistics. Second part is magnetostatistics and electromagnetic induction. First part I am segregating electrostatistics. What is the weightage? 3.5 marks they will ask in CSIR. 1 mark question for GATE. Next, magnetostatistics and electromagnetic induction. There also 5 marks in CSIR, 2 marks in GATE examination they will ask. Maxwell equations and boundary conditions. This is very, very important. 3.5 marks in CSIR, 2 marks in GATE they will ask. Scalar and vector potential and gauge invariance. There also you have to see 5 marks in CSIR, 2 marks questions they will ask in GATE examination. Electromagnetic waves. In electromagnetic waves, 2 questions they may ask. Those 2 questions also long questions in CSIR examination, 1 mark in GATE examination. Optics, this is very, very important. Their optics are related now. Reflection, refraction, polarization, interference, diffraction, total internal reflection, Brewster's law, all the optical phenomena we have to discuss here. So that 3.5 marks in CSIR examination, 1 mark for GATE examination they will ask. Dynamics of a charged particle in electromagnetic field, dynamic of a charged particle in static and uniform electromagnetic field, 5 marks in CSIR, 0 marks in GATE examination. Lorentz invariance of a Maxwell equations. Lorentz invariance of a Maxwell equation, 5 marks in CSIR, 0 marks in GATE examination. Transmission lines and waveguides. This theory is very, very important. 5 marks in CSIR, 0 marks in GATE. Now you have to see Lorentz transformation. These two are not there in GATE exam syllabus. Only they are made for CSIR only. This syllabus is only for CSIR. Lorentz invariance of the Maxwell equations. This syllabus is only for CSIR. Transmission lines and waveguides. This syllabus is only for CSIR. There is no syllabus for the GATE examination. Next, last one, radiation from moving charges, dipoles, retarded potential, 5 marks for CSIR, 2 marks for GATE. The radiation is there in GATE examination also. Once again, you have to clearly indicate that. Or writing the only for GATE, don't prepare for these 2 parts. Lorentz invariance of the Maxwell equation, transmission lines and waveguides. Based on these 10 areas, you have to segregate like this. Each and every area 2 days you have to keep. Maybe you will take the 20 days. So 2 days also not sufficient sometime. So that's why we need to complete this syllabus. 1 month is needed. To complete this syllabus, 1 month is needed to teach. To study, maybe more than 1 month also needed. Based on your first revision and second revision and third revision, you may get within 1 day also you have to do all these things. For each and every question, I have to chosen one old question I will explain to you. Once you have to see, maybe you will get the benefited in free way. This one we are uploading in YouTube also. First you have to see from first area, that is electrostatistics. A static spherically symmetric charge distribution is given by rho of R, the density charge distribution, spherically charge distribution, rho of R is equal to, which one they are asking, Nana? Rho of R is equal to, they are giving A by R e to the power of minus kr they are giving, where A and K are the positive constant. The electrostatic potential corresponding to this charge distribution varies with electrostatic potential corresponding to this distribution varies with R, as June 2011 in CSIR examination they are asking this question. This is very easy. From Poisson's theory, you know one thing. What is the Poisson's equation? Which one it is, Nana? The Poisson equation is, the Poisson equation, once you have to see the Poisson equation, del square V is equal to, what is the Poisson equation? Del square V is equal to minus rho by epsilon naught. Minus rho by epsilon naught. What is the del square? This is a Laplacian operator. Del square is a Laplacian operator. Which operator it is? Laplacian operator. Del square is a Laplacian operator. Once you know the Laplacian operator in terms of a spherical charge distribution, spherically symmetric, you have to take a spherical coordinate of Laplacian equation, Laplacian operator. What is the spherical Laplacian operator? The spherical coordinate of Laplacian operator, spherical coordinate of, once you have to see the spherical coordinate of, which one it is, Nana? Laplacian operator. This is very important. Laplacian operator. The spherical coordinate of Laplacian operator, del square is equal to 1 by r square into, del square is equal to 1 by r square into dou by dou r of r square into dou v by dou r. Dou v by dou r means we have to take it as a dou by dou r. First operator I am writing, plus 1 by r into, which one we have to write, Nana? 1 by r into dou by dou r of r square into dou by dou r into r cap. You have to take it is a operator. So r cap also you won't get it because it is the operator. Del dot del we have to take here, plus 1 by r square sin theta into dou by dou theta of sin theta into dou by dou theta of sin theta into dou by dou theta, plus 1 by r square sin square theta, 1 by r square theta dou square by dou phi square. This is the operator of, in terms of Laplacian operator, in terms of spherical polar coordinate system, right? This is very important. Electromagnetic theory, that coordinates also very important. What is the Poisson equation? Our Poisson equation is del square V. Del square V is equal to, which one we have to keep, Nana? 1 by r square dou by dou r of r square into dou v by dou r, this v I am writing here, dou v by dou r plus 1 by r square sin theta, 1 by r square sin theta into dou by dou theta of sin theta into dou v by dou theta plus 1 by r square sin square theta into dou square v by dou phi square is equal to minus rho by epsilon, minus rho by epsilon or epsilon naught we have to take. This is the Poisson equation. But our rho is equal to, they are giving, rho is equal to which one? Therefore, del square V is directly proportional to rho. From this, which one we have to write? Del square is directly proportional to rho. Therefore, V also is directly proportional to rho. Rho is equal to which one, Anna? We are unable to calculate also here. Rho is equal to, already they are giving, A by R e to the power of minus kr. What is your answer? Your answer also like that only, A by R minus kr only. Now you have to see what is the rho is there. Rho is directly proportional to rho of r. V is directly proportional to rho of r. Rho of r is equal to A by R e to the power of minus kr. That answer only. What is our answer? 1 by r e to the power of minus kr. This is the 3.5 marks they are asking in June 2011 examination. Like that we have to do. Just simple. If they want to ask rho of r, you have to substitute and you will potential you have to substitute there and you have to find that. If they will ask the potential, you have to substitute V here and then you have to substitute the potential here, then you have to calculate the V, you will get the potential from this. They are not asking the potential, they are asking the electrostatic potential corresponding to the charge distribution varies. How it is varying, they are asking. How it is varying? The same entity, they are varying 1 by r e to the power of minus kr only. They are varying. Clear? Now we will see the second one. What is the second one? Once you have to see. This is question I am taking from the magnetostatistics. From 1-1. Among the 10, I have to take 1-1 only. For the demo purpose only, I have to choose like this. Two magnetic dipoles of magnitudes m. Suppose one magnetic dipole is there, that magnitude is m. Another magnetic dipole is there, that magnitude is m. Each are placed in parallel, is in a plane as shown in the figure. Each are placed as shown in the figure. This one is 45 degrees, this one also 45 degrees. M1 and M2, this degree is 90 degrees. How many degrees? It is 90. The energy of the interaction is given by, they are asking. What is the energy of the interaction between the two magnetic dipoles? The energy of the interaction, you know, U is equal to mu naught by 4 pi r cube into m1 dot m2 minus m1 dot m2 minus 3 into m1 dot r cap into m2 dot r cap, your bracket close. This is the interaction energy between the two magnetic dipoles. This one is a formula. What is the interaction energy? U is equal to mu naught by 4 pi r cube m1 dot m2 minus 3 into m1 r cap m2 r cap. This is the formula. From this formula, you have to substitute where m1 dot m2 is equal to m into cos theta. Cos, how many degrees are there between the m1 and m2? Cos 90. Cos 90 is equal to 0. Sin 90 is equal to 1. Cos 90 is equal to 0. m1 dot m2 is equal to 0. Next you have to calculate m1 dot r cap. R cap, it is a unit vector. M into r cap unit vector means that is 1. which one it is the dot product, cos 45 is equal to m by root 2, that is your cos 45 is equal to 1 by root 2, r cap, magnitude of the r cap is equal to 1. Similarly, m2 dot r cap is equal to m into r cap into cos 45 is equal to, because m2 also making the 45 degrees, this one also m by root. Now you have to substitute. How we have to substitute? Once you have to see u is equal to mu naught by 4 into r cube. How much distance is there? Instead of r, d distance is there. That distance is d cube. Between the m1 and m2 distance is d cube. m1 dot m2 is equal to 0 minus 3 into m1 dot r cap is equal to m by root 2. Right? m2 dot r cap is equal to how much value, Nana? M by root 2 is there. Therefore, which one we have to see? U is equal to minus 3 mu naught m square is divided by root 2 into root 2 is equal to 2. 2 into 4 is equal to 4 2 ja 8. 8 5 d cube. What is your answer? The interaction energy minus 3 mu naught m square is divided by 8 5 d cube. Whether the answer is there or not, once you have to check. Minus 3 mu naught m square is divided by 8 5 d cube. Option D is correct. This question is very easy, right? From magnetostatistics they are asking. To get this question, which one we need? This formula is needed. This formula, what is the, if magnetic dipoles they are giving, the interaction of the magnetic dipole, the interaction energy is equal to mu naught by 4 r cube m1 dot m2 minus 3 into m1 r cap into m2 r cap is there. This is very important. So many times like these questions you get in your CSIR examination. Clear? Now we will see the third one. So what is the third one? You have to see the charge distribution inside a material of the conductivity is sigma and permittivity is epsilon at the initial time t is equal to 0. At t is equal to 0, rho of r comma 0 is equal to rho naught, a constant. At subsequent times, rho of r comma t is given by, what is the rho of r comma t is given? It's a very important. This question so many times they are asking. One time they are asking in GATE examination, one time they are asking in CSIR examination. So many times they are asking this type of questions. Once you have to see how we have to solve this question. First, you know the equation of continuity. This is the conductor. In conductor, equation of continuity, you know. What is the equation of continuity? In equation of continuity, we have to write equation of continuity. We have to take that equation of continuity. From the equation of continuity, del dot j is equal to minus dou rho f by dou t. This is the equation of continuity principle. We know that. What is the equation of continuity principle? Del dot j is equal to minus dou rho by dou t. But we know that J is equal to sigma into E. This is the conductivity. Which one it is, Nana? Ohm's law in conductors. Ohm's law in conductors. Ohm's law in conductors. What is the Ohm's law in conductors? J is equal to sigma into E. Now you have to substitute. One more page I have to take. Once you have to take here, del dot J is equal to minus dou rho f by dou t. This is the equation of continuity. J is equal to sigma into E. Now you have to substitute. Maybe you have to take, this is the equation number 1. This is equation number 2. Equation number 2. You have to substitute in equation number 1. You have to substitute in equation number 1. What will happen? You have to see del into sigma into E is equal to minus dou rho f by dou t we have to take. Now the sigma you have to bring outside. Sigma into del dot E is equal to minus dou rho F by dou T. By using the Maxwell equations, what is the del dot E is equal to, this is the Gauss law, del dot E is equal to rho F is divided by epsilon naught is there, del dot E is equal to, this is the differential form of Gauss law. Differential form of, which one it is, Nana? Gauss law. Gauss law. Differential form of the Gauss law, del dot E is equal to rho epsilon by epsilon naught, but it is not a free space. It is whom, Nana? This space is conducting medium. That's why you have to take epsilon. Conducting medium, you have to take epsilon. Therefore, from this, what we have to take, Nana? Sigma into del dot E is equal to, which one we have to write? Rho F by epsilon is equal to minus dou rho F by dou T. Minus dou rho F by dou T. Now I am rearranging the expression. How I am rearranging the expression? You have to see dou rho F by rho F is equal to minus sigma by epsilon into dou T. Can I write like that? You have to integrate on both sides. How I am integrating? Rho naught. What is the rho naught value? R comma 0. So rho naught, rho R comma T. Our integration T is equal to 0 to T is equal to T. You have to substitute the limits. Integral dx by x is equal to ln x. Ln rho f is equal to rho naught, rho f of R comma T, rho naught R comma 0 is equal to minus sigma by epsilon into T we have to take. Now you apply the upper limit and lower limit. Ln rho f is divided by rho naught is equal to minus sigma by epsilon into T. Now you have to remove the logarithmic symbol. How I am removing the logarithmic symbol? Once you have to remove the logarithmic symbol, rho f by rho naught is equal to exponential of, this minus also is there now, minus sigma by epsilon into T. Sigma by epsilon into T. Therefore, rho f is equal to rho naught into exponential of minus sigma by epsilon into T. This is the resistivity of charge density. Rho f is equal to rho naught into e to the power of minus sigma by epsilon into T. Once you have to check the answer, so whether it may be there or not, you have to see. What is the subsequent charge density? Rho naught exponential of minus sigma by T into T. What is your option? Option A is correct. This question is very, very important. So many times they are asking this question. Here Maxwell equations is involving. Here the conductivity, Ohm's law is involving. Here how we have to involve the integration also involving. Like this we have to solve. Just simply we won't get the answer. We have to solve. Then only we will get the option. This question they are asking in June 2017 CSIR examination. They are asking this question. I took from the Maxwell equations, I took this question. Clear? Now you have to see. Next question. What is the next question you have to see? The next question is, there you have to see a constant electric current I, in an infinitely long straight wire. Once you have to take, this is a infinitely long straight wire. There is a I current is going. That current is a constant current. Which current it is, Nana? Constant current is going. That current is a constant current, right? I is a constant current. So then is wire is switched on at t is equal to 0. At t is equal to 0, this wire is switched on.
the vector potential at perpendicular distance from the wire is given by, they are giving the vector potential, that vector potential is equal to minus k cap mu naught I is divided by 2 phi ln 1 by r ct plus square root of c square t square minus r square is there. The electric field at a distance r is less than ct is given. They are asking the electric potential. The electric field they are asking. Electric field they are asking. What they are giving? Electric. So vector potential they are giving. If you have to take a constant current, what is the scalar potential? The scalar potential is equal to, if you have to take a scalar potential, the scalar magnetic scalar potential is equal to, for a solid angle, I solid angle is divided by 4 phi. Here what is I? I is a constant. I is the constant. I you have to take it as a constant. Therefore, how we have to calculate the electric field once you have to see. The electric field, if we know the scalar potential and vector potential, how we have to calculate the electric field, that is very, very important. E is equal to minus gradient of phi minus dou A by dou T. This is the formula. Minus gradient of phi minus dou A by dou T. But here, what is the phi nana? E is equal to minus gradient of phi is equal to, which one we have to write here? I omega is divided by 4 phi. This is the constant value. It one is a constant, all are constant. That's why this entire thing, it will goes to 0, right? Minus dou A by dou T. Minus dou A by dou T. They are giving the A value. Therefore, E is equal to, which one I have to write? Minus dou A by dou T. They are giving the vector potential. What is the vector potential? A is equal to, they are giving the value once you have to see, k cap mu naught I by 2 phi, k cap mu naught I by 2 phi, mu naught I by 2 phi ln, which one they are asking nana? Ln 1 by r into, ln 1 by r into, which one they are taking? ct plus square root of c square t square minus r square. This is the thing they are giving. C square, 1 by r into ct plus c square t square minus r square, they are giving the value. Now we have to see how we have to solve this one. Just you have to do the integration, you will get the answer. E is equal to minus dou by dou T of, instead of A you have to substitute k cap mu naught I is divided by 2 phi, mu naught I is divided by 2 phi ln into 1 by r into ct plus square root of c square t square minus r square you have to take. C square t square minus r square. What are the, with respect to whom we are differentiating? With respect to time. Whatever the constants are there, those constants you have to take outside. E is equal to minus k cap mu naught I is divided by 2 phi. These are all constants. D by dt of ln x. D by dt of ln x is equal to 1 by x. Now you have to see d by dx of ln x is equal to 1 by x. From this we have to take r is divided by something is there. I am writing the reverse. R is divided by ct plus square root of c square t square minus r square. Again you have to differentiate this one. Again you have to differentiate this entire part. This is one you have to take it as a x. Again you have to differentiate this x value. How it will come, the x value with respect to t? 1 by r into, you have to differentiate this one, c it will come, plus c plus is divided by root x, you have to differentiate. Again you have to take it as x, root x you have to differentiate 1 by 2 root c square t square minus r square. Again you have to differentiate this one. Which one you have to get, Nana? 2t square t minus r square is equal to 0. You have to get it. R get cancel. R get cancel is there. Now you have to simplify. E is equal to minus k cap into mu naught I by 2 phi. Mu naught I by 2 phi. Here 2 1 ja. Here 2 1 ja get cancel. Right. Now you have to take it here. Ct plus square root of c square t square minus r square in the denominator as it is I am writing. Here you have to take it is. So which one you have to take, Nana? C into, here you have to take the common, C you have to take the common. C you have to take the common. What will happen? 1 plus Ct. 1 plus Ct is divided by, this one is divided by square root of c square t square minus r square is there. Now I am again rearranging once you have to see. E is equal to minus k cap is divided by 2 phi into mu naught I into c also you have to take here now. Now is divided by, which one I am writing? Ct plus square root of c square t square minus r square. This is close. Now again you have to LCM, you have to do square root of c square t square minus r square plus ct is divided by square root of c square t square minus r square is there. Now this one get cancelled. You have to take it as a this one and this one get cancelled. The rest of the thing you have to write, that is the E value. Therefore, E is equal to which one we have to write, Nana? Minus k cap mu naught IC is divided by 2 phi into square root of c square t square minus r square. This is your answer. Now once you have to check whether it may be answer is there or not. Once you have to check here, there is the answer is there. Minus k cap mu naught IC is divided by 2 phi into c square t square minus r square. Option D is correct. Like this we have to calculate. To calculate this, what we know? We know the electric field formula. E is equal to minus gradient of phi minus dou A by dou T. This is the formula under scalar vector potential. If they gave the scalar vector potential, we have to calculate the electric field by using this formula. Sometimes they are asking directly formula also. Some local exams they are giving directly formulas also. But this exam is to enhance your capability. So that's why they will ask like these questions. They will ask whether you may get this type of questions or not, like that they will see. This is the calculation we have to do. So that's why if you want to know whether it may be electromagnetic theory or classical mechanics or quantum mechanics, any subject in physics, you have to thorough in mathematical methods of physics. If you know the mathematical methods of physics very well, all the subjects you have to do very simply. Otherwise, it is very difficult to solve the problems. You are unable to understand what they are asking, what they want to ask. Entire the thing is different. Clear? Now we have to see the next one. What is the next one we have to see? Right. The electric and magnetic fields they are giving. They are giving the electric field. What is the electric field they are giving, Nana? Once you have to see ER comma T is equal to E naught e to the power of minus K1Z cos K2X minus omega T J cap. This is the vector. Electric field vector they are giving. The magnetic field also they are giving. B of R comma T is equal to E naught by omega e to the power of K minus K1Z into K1 sin K2X minus omega T into I cap plus K2 cos k2x minus omega t into k cap. They are giving this electric field and magnetic field where omega, k1 and k2 are the positive constant. The average energy flow in the x direction they are asking. The average energy flow in the x direction means because of the I cap direction. Average energy flow. The average energy, first you have to find the Poynting vector. Poynting vector is equal to E cross H. H is a magnetic field. E cross H is equal to B by mu naught. Therefore, S is equal to, this is the energy flow vector. Poynting vector, which vector it is? Poynting vector. This is very, very important. Poynting vector S is equal to E cross B is divided by mu naught. You know the E and B. Next you calculate the E cross B. How we have to calculate? Once you have to see. First you have to calculate the Poynting vector. Then you have to do the average of the Poynting vector. First S is equal to E cross B is divided by mu naught. What is the E value? Already you know the E value. E is equal to E naught e to the power of minus k1z cos k2x minus omega t into j cap. Which one it is, Nana? E naught e to the power of minus k1z into e to the power of E naught e to the power of minus k1z into cos k2x minus omega t into cos k2x minus omega t into j cap. Correct? This is the E naught value. Cross, which one we have to write? This is the cross product. Is divided by, you have to do here mu naught cross a B value. What is the B value? E naught by omega. We have to write here E naught by omega e to the power of minus k1z into, which one we have to write, Nana? K1 into sin k2x minus omega t, sin k2x minus omega t into which cap it is? I cap into I cap, plus we have to take it as a k2 into cos k2x minus omega t into k cap. This is the B value. Now we have to do a cross product. How we have to do the cross product? Once you have to see whatever the numbers you have to take here. E naught square is there. Here 1 E naught, here 1 E naught is there. E naught square. Here 1 e to the power of k1z, e to the power of minus k1z, e to the power of minus 2k1z is divided by, here divided by omega, mu naught omega, this mu naught omega into I cap, j cap, k cap I am writing. So what is the j cap? I cap is equal to 0 here, j cap is equal to cos theta I am writing, where theta is equal to, I will take the latter after time, theta is equal to, we have to take it as a k2x minus omega t you have to take, right? Next I cap is equal to k1 into sin theta, k1 into sin theta, right? Here we have to write a j cap 0, k cap is equal to k2 into cos theta, k2 into cos theta we have to take, right? Now you have to multiply the determinant. How we have to multiply the determinant? Only I cap we need, because x coordinate along the x direction we need only I cap. Cos theta into cos theta, k2 cos square theta we are getting into I cap. Into this part, rest of the part we need not, because they are asking only the x direction. That's why I am taking that one. Therefore, S is equal to along the x direction. S along the x direction is equal to E naught square into e to the power of minus 2kz is divided by mu naught omega into I cap k2 cos square theta. But what they are asking? The average energy flow. Average energy flow. Pointing vector is nothing but a energy flow. What is the average energy flow? Average of the pointing vector you have to do. Average of the pointing vector E naught square is equal to E naught square e to the power of minus 2 k1z into k2 is divided by mu naught omega. So average of the cos square theta. Average of the cos square theta is equal to 1 by 2. So therefore, average of the energy flow is equal to E naught square e to the power of minus 2 k1z. K2 is divided by 2 mu naught omega we are getting. This is very, very important because the average of cos square theta is equal to 1 by 2. Clear? Like this we have to do. So now you have to see the option, whether it may be option is there or not, you have to see that option is there or not. You have to see here E naught square K2 2 omega naught mu naught omega e to the power of 2 k1z. Option A is correct. Which one is correct, Nana? Option A is correct. That is very, very important. Option A. Here option B, 2 mu naught is not there. In option C, so K1 is there. In option D, this one is not correct. Clear? Like this we have to calculate. Formula is very simple. You know the pointing vector. You know the energy. That one also you come to know in your brain. The average energy flow. What is the average energy flow? Average energy flow means what? That is also they will ask. Like that they will ask the questions in CSIR. Not easy. You have to think in different way. You have to exercise in many times. Then only you will get the perfection. Otherwise it is very difficult to solve the problems. Right? Clear. Now we will see the sixth one. This is very, very important. From optics they are making the question. Every time they are asking in CSIR GATE, whether it may be GATE 1 mark question they will ask in optics part. 1 mark question. Whether it may be CSIR 3.5 marks question in CSIR. In GATE examination if you have to write, only 1 marks you will get from optics. When CSIR examination you have to attempt, that is 3.5 marks question they will ask. Now here you have to see what is they are asking. In an interference pattern formed. In an interference pattern, how it will be formed? Interference formation it will. This is the minimum. This one is the maximum. Again minimum and maximum. Minimum, maximum, minimum and maximum. This is the distribution of the interference pattern. Two coherent sources. The maximum and the minimum intensities they are giving. The maximum intensity I maxima is equal to A1 plus A2 whole square is equal to they are giving. How much value they are giving? 9 I naught they are giving. I maxima is equal to 9 I naught and they are giving the minimum intensity. The minimum intensity, what is the minimum intensity? I minima is equal to A1 minus A2 whole square is there. This is the minimum intensity. That minimum intensity they are giving, I naught they are giving. What they are asking? What is the I1 and I2? Individual intensities I1 and I2 is equal to how much they are asking. Individual intensities they are asking. What is the intensity? Intensity is equal to the square of the amplitude they are giving the intensity. Once you have to see how we have to solve. First, the intensity means intensity is equal to the square of the amplitude. Therefore, similarly we have to write I1 is equal to A1 square. Therefore, A1 is equal to the square root of I1. Similarly, what should I write, Nana? Similarly, the square root of I2 is equal to A2 we have to write. The square root of I2 is equal to A2. Which one we need to calculate? What is the I1 and what is the I2 we have to calculate. Now you have to see. I maxima is equal to, what is the formula? A1 plus A2 whole square is the formula. What is A1? Square root of I1 plus square root of I2 whole square, which is equal to I maxima is equal to square root of A1 and square root of A2. I maxima is equal to how much value they are giving, Nana? 9 I naught they are giving. Which one they, how much value they are giving? 9 I naught they are giving. 9 I naught is equal to, 9 I naught is equal to square root of I1 plus square root of I2 whole square. Square root of I1 plus square root of I2 whole square is there. So now you have to see here how we have to write here. Once you have to see 3 root I naught. 3 root I naught whole square is equal to, which one I have to write? Root I naught, root I1 plus root I2 whole square I am writing. So square get cancel. 3 root I naught is equal to root I1 plus root I2. This is the equation number 1. First I am writing. Next, similarly, you have to do for that. How you have to calculate, Nana? I minima you have to calculate. I minima is equal to A1 minus A2 whole square. I minima is equal to which one? A1 minus A2 whole square. Therefore, I minima is equal to A1 means root I1 minus root I2 whole square. Root I1 minus root I2 whole square. I minima, how much they are giving? I naught they are giving is equal to root I1 plus minus root I2 whole square. Therefore, root I naught whole square is equal to root I1 minus root I2. Can I write whole square? Whole square get cancelled. Therefore, root I naught is equal to root I1 minus root I2. Root I1 minus root I2. This is the equation number 2. First you have to take the first expression. What is the first expression? Root I naught is equal to root I1 minus root I2. You subtract these two equations, you add it, you add. So this one get cancelled. 2 root I1 is equal to 3 root, so 3 plus 1 is the 4. 4 root I naught it will come. 2 1 ja, 2 2 ja. If you want to get the root get cancelled, square it. What will happen? You have to see. So which one you have to? Root I naught is then 2 root I naught is equal to root I1. Root I1. You square on both sides. What will happen? You have to square on both sides. 4 I naught is equal to I1 we are getting. What is the I1 is equal to 4 I naught. This is 1. First intensity. Next, what you have to do? You have to subtract it. What you will get? 3 root I naught is equal to root I1 plus root I2. Root I2. First you subtract. So subtract the symbols. What will happen? You have to see 3 root I naught. We subtract from higher to lower, lower to higher. You have to subtract. What will happen? You have to see here. You have to subtract whether it may be this one. It will become as a minus 2 root I naught is equal to minus 2 I2. I2 get cancelled. Minus get cancelled. Root also get cancelled. Therefore, I2 is equal to I naught you are getting. What is your options? Now, once you have to check it, the individual intensities. What are the individual intensities? 4 I naught and I naught. First, I1 is equal to 4 I naught and I2 is equal to how much value you are getting, Nana? I naught value you are getting. This is very, very important. For how many marks they are asking? For 1 mark question, 2013 GATE examination there. Like this we have to do. First, you know the interference pattern. This is intermediate level question only, right? Maybe if you are unable to know the formula, you are unable to know the process of the solving, you are unable to do these options, right? These options also complicatedly they will ask. Once you have to see, like this they will ask. This is the purely optics question. From degree people also this question they will do. Now, you have to see a charged particle. This is the 7th one. A charged particle in static and electromagnetic field. Uniform electromagnetic field. Under this syllabus, I took this question. Once you have to see here. A charged particle moves in helical path. Charged particle moves in helical path means helical path. Helical path means here two types of velocities are there. Parallel velocity and perpendicular velocities are there. Helical path is, if it is a parallel velocity, that will goes to the in straight path. If it is a perpendicular velocity, it will go in a circular path. If it is a combination of two paths, so what will happen? This particle is a circular plus straight path. We call it as a helical path. Right? What is the thing they are giving? A charged particle moves in a helical path under the influence of a constant magnetic field. Under the constant magnetic field, that charged particle is moving like this helical path. The initial velocity is such that the component along the magnetic field is twice. They are giving the initial velocity. The initial velocity, how they are giving? The initial velocity is such that the component along the magnetic field is twice the component plane normal to the magnetic field. What they are giving, Nana? V parallel is equal to 2 into V perpendicular. They are giving V parallel is equal to, that condition is giving in the problem. Not I am writing. In the problem only they are giving. The initial velocity is such that the component along the magnetic field. The component along the magnetic field means parallel. The component along the magnetic field is twice the component in the plane normal to the magnetic field. Component in the plane normal to the magnetic field. The ratio of the L by R, the pitch, L is a pitch value, to the R is the radius of the helical path is. Radius of the helical path they are asking. How we have to calculate? Once you have to see. First, what they are giving, Nana? They are giving the parallel velocity is equal to 2 into perpendicular velocity. What is the pitch of the helical path? There is a formula is there. The pitch of the helical path is equal to pitch of the helical path. Pitch of the helical path is equal to, what is the formula, Nana? That helical path is L. The pitch of the helical path L is equal to V parallel into time period, T. V parallel into time period, right? V parallel, you know, V parallel is equal to 2 into V perpendicular. The time period is equal to 2 pi r is divided by, the circumference of that is divided by V perpendicular. V perpendicular get cancelled. Therefore, L is equal to 2 into 2, 4 pi r. What they are asking? L by R is equal to how much they are asking? L by R is equal to how much? The ratio of the, so the ratio of the pitch of the helical path to radius of the helical shape is equal to how much it is, Nana? 4 pi. This is very, very important. They are asking in December 2014, they are asking. What is your option? Your option is 4 pi is correct. Option B is correct. This is a pitch of the helical path. Clear? Like this we have to calculate. This is very, very important. How you have to follow like this, we don't know. Now once you have to see here, the 8th one, which of the following is a low-range invariant? Some low-range invariant is there. What is the low-range invariant? Suppose one frame of reference is there, another frame of reference is there. One frame of reference means it is a laboratory frame of reference. It is the center of mass of frame of reference. Maybe some frame is moving along the reference frame. What will happen? You have to see. In one frame, one coordinate is there. In another frame is also that coordinate is existing. Such type of thing, invariant. There is no variation. Invariant means there is no variation. How we have to express the invariant? Once you have to see. Some formulas are there. Those invariants you have, I will give the 5, at least 5 invariants I will give. Charge is a invariant under the low range transformation. under the Lorentz invariant coordinates. What are the Lorentz invariances? Charge. Number 2 is the electric field square minus the magnetic field square. So this is a invariant. Number 3 is the electric field dot the magnetic field is also invariant. Number 4 is x square plus y square plus z square minus c square t square is equal to 0. This is the invariant. Number 5 is e square minus p square c square is equal to, which one we have to write? This is also invariant. Number 6 you have to see box square. This is a Dielectrics operator. So what is the Dielectrics operator, Nana? The Dielectrics operator is del square minus 1 by c square into dou square by dou t square. This is the Dielectrics operator. This Dielectrics operator also invariant, right? Which one it is? Invariant. Like this invariants are there. Now you have to check it. E cross B is not correct. Option B is there under the Lorentz invariances. What is the Lorentz invariance? Modulus of E square minus modulus of B square is a Lorentz invariant. Under the Lorentz invariant, this option is correct. This option is wrong. E dot B is correct. This option also wrong. This question came for a 5 marks question. Just you have to remember this. Sometimes they are asking in some gate examination, they are asking what is the Lorentz invariant charge or electric field E dot B or this one they are asking. Please remember this. Not only this, total 10 is there. Those things I will give. If you have to join in my coaching institute, I will give all the Lorentz invariance quantities. Clear? This is the under Lorentz invariance. This is the 8th one. Now we will see the 9th one. What is the 9th one you have to see? This question, transmission lines under waveguides. This is very, very important. This question I make it from the waveguides. Their magnetic field they are giving H0 into cos 0.35x into cos 0.45y they are asking. Now you have to compare with this. The dimensions of AB is there. Hz is equal to H0 into cos. You have to take m phi by a into x cos n phi by b into y. You have to compare. Now you have to take it here. M phi by a is equal to 0.35. 5 you have to get cancelled. The dimensions of a is equal to m is equal to how much is there, Nana? M is equal to, this is a TE11 mode. TE11 mode means TEMN, where m is equal to 1, n is equal to 1. Therefore, you have to substitute a is equal to 1 by 0.3. If you have to take 1 by 0.3, what is that value? 3.33 centimeters. It is a dimension. Now you have to see. Therefore, n phi by b. N phi by b is equal to how much it is there? 0.4. 5 get cancelled. Therefore, b is equal to 1 by 0.4. 1 by 0.4 is equal to 2.50 centimeters. But what they are asking about the cutoff frequency. The cutoff frequency for this mode Fm comma n is equal to c by 2 into square root of m by a whole square plus n by b whole square. This is the formula, cutoff frequency formula. M by a whole square plus n by b whole square. You know all the values. C is a light velocity, 3 into 10 to the power of 8 meter per second into 2 into square root of m is equal to 1, a is equal to 3.33 whole square plus 1 by b is equal to 2.5 whole square. If you have to do this one, you are getting 7.5 gigahertz. You have to get it 7.5 gigahertz. You are getting that value. What is your option? According to that, 7.5 gigahertz you are getting. So mega means 10 to the power of 6. Mega means 10 to the power of 6. Giga means 10 to the power of 9. Giga. Because already here 10 to the power of 8 is there. One more 10 also will be added. That is 7.5 gigahertz cutoff frequency you will get it. This is the waveguide question. Based on the waveguide, we have to do this one. Next, last one. How we have to do the last one? It is a radiation part. In the radiation, dipoles are there, retard potentials are there, powers also is there. This is very, very important question you have to see. An electron is decelerated at a constant rate starting from initial velocity u2, u by 2, u by 2 during which travels a distance s. During which travels, how much distance travel? Distance travel, yes, distance is travel. The amount of energy lost because of the radiation is. Now the radiation, suppose sun is illuminating. Sun is illuminating every second, every hour, every day. They are reducing the energy. They are reducing the energy means energy is lasting. How much power is generated? That is very, very important. The total radiated power, this is the Larmor principle. Total radiated power, which one we are writing? Larmor principle. Which principle it is? Larmor principle. This is very, very important. Total radiated power. P is equal to mu naught q square a square is divided by mu naught q square a square is divided by 6 phi c. This is the total radiated power. But which one they are decelerating? Electron is decelerating. Instead of electron, q is equal to E we have to write. Therefore, our power is equal to mu naught E square A square is divided by 6 phi c. This is the Larmor's power. But how much energy is generated? That energy is equal to, how we have to write, Nana? Energy is equal to power into time. But you know one thing, how we have to calculate this one, you have to see. The energy is equal to power into time. But power we know, power is equal to what we have to take that power? That power value mu naught E square A square is divided by mu naught E square A square is divided by 6 phi c. This is the power, right? Next, T value we have to see. How we have to calculate the T value? By using the kinematics equation, V is equal to U plus AT, but our acceleration, decelerated acceleration, that's why what we have to take, Nana? Minus A you have to take. Which one you have to take? Minus AT. This is the decelerating acceleration. But our U, it will become as a U by 2. U is equal minus AT. We have to take that one. We have to write it as a U minus AT. Therefore, AT is equal to U minus U by 2. AT is equal to U by 2. T is equal to U by 2A. This U by 2A you have to substitute here. Therefore, how we have to write once you have to see, E is equal to mu naught E square A square is divided by 6 phi c into U by 2A we have to write. Which one we are writing, Nana? U by T. This E is equal to mu naught E square A square U is divided by 12 phi c A. 1A get cancelled. Therefore, E is equal to mu naught E square AU is divided by 12 phi c we are writing. This is the energy. But this energy we are not asking. What much of the energy lost? The fraction of an initial kinetic energy lost, we have to take that one. The fraction of initial kinetic energy lost due to radiation. Due to the radiation, some energy is lasting. That energy they are asking, what is the fraction of initial kinetic energy lost due to the radiation is equal to E is divided by 1 by 2 mu square. This is the kinetic energy. But you write 2E is divided by 1 by 2 mu square. Now you substitute here 2 into mu naught E square AU is divided by 12.5C into U square. 1U get cancelled. But we have to substitute the A value. How we have to substitute? S is equal to ut plus half at square. This is the kinetic equation. But this decelerating acceleration, that's why you have to take it is a minus u. S is equal to u. T is equal to, already we know, T is equal to which one it is, Nana? U by 2A minus 1 by 2 into A. T square is equal to U square by 4A square. U square by 4A square we have to write. 1A get cancelled. There we have to write it S is equal to U square by 2A minus U square by 8A is there. You take the LCM. You have to take the LCM. Which one it is the LCM, Nana? S is equal to 8A LCM you have to take. 8A LCM you have to take 2 4 ja 8. 4U square minus U square. Therefore, S is equal to 3U square by 8A. From this, A is equal to, you have to write A is equal to 3U square by 8S. This S value you have to substitute here. Where you have to substitute? Instead of A, you have to substitute there. How you have to substitute? Once you have to see 2 1 ja, 2 6 ja. Therefore, the fraction of initial kinetic energy lost, one more page I have to take because space is not there. The fraction of initial kinetic energy lost, the fraction of initial kinetic energy lost during the radiation is equal to, how much we have to write? During the radiation is equal to, now you have to see mu naught E square U. Mu naught E square U into A is divided by 6 5 C square, 6 5 C square, 6 5 C, 6 5 C into U is there, 6 5 C into U. Which one we have to write, Nana? 6 5 C into, this is the C, 6 5 C into U is, U also is 1 U get cancelled now. Mu naught E square A, 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 mu naught E square A is divided by 6 5 C into U. 6 5 C into A value how to substitute? Mu naught E square by 6 5 C into U. A is equal to, how much value we are getting? 3U square by 8S. 3U square by 8S. 1U get cancelled. Therefore, 3 mu naught E square U is divided by 3 mu naught E square U is divided by 8. So, 3 1 ja, 3 2 ja. So, you are getting 16 5 CS. 16 5 CS. This is the answer. Mu naught E square U is divided by 16 5 CS. Whether this answer is there or not, you have to check it, right? Instead of the option, you have to see mu naught E square, mu naught E square. So, which one? U square is divided by 16 5 MCS. Option D you are getting. Once you have to check it, whether it may be any deviations are there, you have to see here. where we have to substitute it. Here we have to substitute 2e by mu square, tu by mu square, 2e, 2 into mu naught e square au is divided by e value. This one is, au is divided by 12 phi c into m also is there here. M, right? M u square is there. 1 u get cancelled. Therefore, u into u square it will come. Therefore, you are getting the value that here m also will be existing. Sorry, m also will be existing. M also will be existing. Once you have to check, so you are getting the option D. You are getting that is the correct option. That correct option is mu naught e square u square is divided by 16.5 mcs. You are getting this option. This option is correct. Like this you are getting. This is very, very important. From the radiation, I took this question. Total 10 areas I segregated. 10 areas, one area, one question I gave to you. This is the standard of CSIR and GATE. Once you like my teaching, you have to download from your Play Store. Which one you have to take? From your Play Store, you have to download my app, Quantum Online Academy app. That batch will start from 7th January 2024 onwards. Live plus recording classes are there. So that batch will start. This is a 1-year batch. Please download from your Google Play Store that app. From that app you have to purchase the course and then you have to join. Then you listen the classes. Thank you. Thank you for listening your patience. Please subscribe and share my channel to your friends to make them as a subscriber. I will give the good quality of the introduction of all the physical phenomena and physical concepts also I will keep in YouTube. You have to learn my side.